All right, this is Trigonometry 2 final semester review. So I'm going to go over every single one of these problems, and I'm going to go over a lot of stuff, and not just by the calculator, but I'm going to do all of them, not just like basic how to solve it, but I'm going to show you guys how to solve it by hand too. So for some of these, okay, we're going to take this and we're going to do the test over 2 days because there is 40 questions. So we need to actually have the time for that. Okay, so reference sheet, I'm going to keep referring back to this back and forth. Okay, so the first one. We have, so I'm going to work my way down here. See if I can zoom a little bit. There we go. All right, so now for this one right here, this is just an inverse of this one right here. But when you grab that calculator, what do you got to make sure of before you do this?
Degrees.
Degrees. You got to make sure it's in degrees to be able to do this. So go ahead, input that in the calculator and see what we get. So if you notice, I'm starting off right here in radian. So I'm starting out in radian. So document, settings. Oh crap. Settings, document settings. So I'm going to change mine to degrees. And the biggest, not gradient. The biggest issue we're going to have in this is going back and forth from degrees to radian and understanding when each one is appropriate. So for this right here, inverse cosine, trig, inverse cosine, and it's going to be 0.2063. Enter, and I get 78.09. So my answer is C. So I'm kind of doing it out of order. I'm just going to do with what we have on the right here. So now for number 4, I could do 4, same thing in the calculator. So if you're struggling on this one right here, you can go directly to the calculator. Plug it all in to see what we get. Now, for this one right here, this one's actually arc cosine. So it's asking where is cosine equal to this. So the properties for this, so now the domain for an inverse cosine is in quadrant 1 and quadrant 2. So where cosine is going to be negative is going to be in quadrant 2. So this is going to be actually 135 degrees if I try and find out where this is. So this gives me 135 degrees for what we have here. Now on the outside I'm working my way out, so it's asking for the tangent at 135. So we know tangent is sine over cosine. So now at 135 degrees, it's going to be my positive rad 2 over 2 divided by negative rad 2 over 2, which when I put those together, it's going to give me a -1. So my answer there has to be C. Or if you just plug it all in the calculator as is and make sure you put it in correctly, you should still get the same answer out of it. All right, so the next one is number 5. So on number 5, what's the value of this one right here? Now, I'm going to show you how to put it in the calculator. So some of these are a little bit more complicated. So yes, you would do it the same thing. So what is sine 1/2? This one right here is going to be 30 plus inverse tangent of this. Okay, so you can go through and do each one, find the angle for each, add them together, and find the sine of that. Or, like I said, I would show you, is we're going to put in the calculator and as is. So I'm going to go with sine of, so I have my inverse sine, and there's, I'm going to put my 1/2. So 1 over 2, close that parentheses, plus sine, and it's going to be inverse tan of negative rad 3, close. So I close that one right there for my tangent. I close the second one for my sine that I opened up over there. Hit enter, and I get -0.5. So that as a decimal is going to be my negative, or a fraction is going to be my -1/2. Questions on that one? Is everyone good there? All right. If you have questions, please speak up because this is.
Well, you don't have to put the brackets.
No, don't bracket.
They're
Use
just,
parentheses.
They're just parentheses.
Yeah, so just parentheses on that one. Anyone else? Okay. All right, so let's take a look at, now the next one is number 2, because we're working just down the page. And it's asking for what is sine, so we have sine wave here, and saying what's the domain of the inverse. Now, the domain is usually the x values, but if it's doing the inverse, it's now your y values. So it's here to here. So if it's the domain of the inverse, it's now asking for the y values. The y values are going from -1 to +1. So that's going to be here. Or we look at it, it's on the reference sheet. I have another one here. So on the reference sheet, I'm going to come back to this one right here. So for the reference sheet, inverse function of sine, the domain is from -1 to 1. Actually has it right there too. So I will refer back to this one often for this. So we could get it from the graph or we can get it from the reference sheet. All right, so on number 6. Number 6 is the one that we actually had the most trouble with. Now, if this was the exam with the short answer, I would go through this a little bit more thorough. But since this is the final exam and you have 40 of these questions, I'm going to go directly to how to teach you guys do this in the calculator. We've already done it before. So now when we do in the calculator, we have to pay attention to this right here. So what do we have to change? It's got to be degrees, right? But what does it got to be?
360.
0 to 360. So my new window's got to be from 0 to 360. So I have to change it like that. So in my calculator, I got to set that one up. Now, I plug this piece in the calculator, so it's going to be rad 3 tangent tangent should be of x right here. Now, what else do I have to make sure I'm doing when I do this? Degrees, forced degrees. I have to put a degree symbol here. I have to put a degree symbol and then -1. Okay, don't put equal to 0 because it will not graph it if it says equals 0. So, let's go ahead and set it up in our calculator. So, into my graph. So, I'm going to enter my function, bless you. 3, arrow over, tangent of x degrees, got to force that degree, close, and then -1. So that's what I have right there. That's what goes in there. I hit enter. Oh, my calculator doesn't throw it. What's wrong? Okay, what's wrong with it there? I didn't put 0 to 360. So I go menu, window settings, and what do I change? X values. Do I change the Y values?
No.
No. 0. 360. Hit enter. So I have my answers right here, right? So my answer is going to be right here. So I'm going to do menu, analyze graph, number 6. And then I'm going to go to 0, which is 1. So I'm going to click here, drag it across, and that gives me my point of 210. And let's find that other one. So menu 6, 1. Do it again over here for this one because it crosses the x-axis over there. And my other one's going to be 30. Does it look like it crosses anywhere else?
No.
No. Now my answer, I have our degrees.
You have to have it in radian.
Have to have it in radian. So how do we convert this to radian?
Look at a circle.
Okay, you could do a unicircle, or we know it's 30 over 1 times pi over 180, right? Pi over 180. So when I multiply this and then reduce, it's basically going to be 30 over 180, which is going to give me just pi over 6. Now, pi over 6 is my 30 degrees. And the other one, my 210, if I do my conversion, I get
7 pi over 6.
7 pi over 6. There we go. Like I said, you could check it on the unit circle. So 30 and 210. So 30 is pi over 6. 210 is right here, which is 7 pi over 6. So it is on my unit circle. It is on the reference sheet. Answer has to be C. All right, number 3. 3 is a special one because they ask you for sine, but they give you sine. Because it's arc sine, it's asking for, hey, arc sine, what is the angle when sine is 1/2? What is the angle when sine is 1/2? Say 30.
30 degrees.
Yep, 30.
30 degrees. Then it's asking for the sine of 30 is, what's the sine value at 30?
Square root.
Say 1/2.
1/2. Oh.
Okay, so this one right here, it's they ask you for sine, but they already gave you sine. They gave you the sine value and they already asked for it. So it's kind of weird like that. But still, guess what?
Calculator.
Got to get it right anyway. So you can put it in the calculator, right? As is, and you get your answer. You'll get your answer out of that. Now, on number 7. 7, where do I get those answers?
Reference sheet.
Reference sheet. So, domain and range of inverse secant.
Negative infinity minus negative 1.
There we go, right here, right? So all of that right there. So my answer has to be,
Duh.
that's what matches it, right?
Duh.
Okay, anyone have any questions?
No.
Okay, all right, let's go ahead. Next page, number 8. All right, so on this one here, this is another one that I just plug in the calculator, right?
Yes.
So since I'm plugging in the calculator, how do I have to do this first before I can do that?
Subtract sine.
Subtract what?
Sine.
Subtract sine. Why?
Because what
I have to have it,
equals 0.
thank you, very good. I have to have it equal to 0, right? It's got to be equal to 0, so it's going to be sine. I'm going to show you how it goes in. 2x degrees. So I need to subtract sine from both sides to get it equal to 0. Minus sine x degrees. So this is what I'm plugging in my calculator, right?
Yeah.
So we're plugging that in. So tab, change this one. So if you want to clear the calculator completely out, you just press Dock B. But I'm not going that far because I don't want to change my window right now. So sine 2x degrees, close, minus sine of x degrees, close. Let's see what we get. We get a whole bunch of them here. So it looks like right here, see how it actually closes in right there? It looks like it crosses at the very beginning, right?
Yeah.
So what do you think the answer is going to be if it crosses right there at the very beginning?
0.
0. So 0 is going to be one of my answers. So menu. So I'm going to do analyze the graph again. So I'm going to find this next one, which is here. There we go. Menu 6, 1. So I'm going to find the next one. Here, let me move this.
300.
There we go. Hold on. There we go. And menu 6, 1.
Oh, look who walked in.
So for this one right here,
0, 60, 180, 300.
0, 60, 180, and 300. Okay, 0, 60. Okay, 0, 60, 180, 300. My answer is D. All right.
And it's the same thing for the next one.
Yep, very good. So we do the same thing for the next one then. So we could do the same thing on the next one.
Subtract 2.
So let's go ahead and I'm going to go. So my problem is going to be 2 cosine x degrees squared. Now I have to subtract 2 from both sides. Okay. And so that's what I'm going to plug into my problem. So hit tab again. So I'm going to go up and change this one. So 2 cosine x degrees, close. Now this is where you put the square at, and then minus 2. There we go. We have my graph right here. Now, and it looks like I have an answer way over here. Looks like that one's going to be 0. Now, can I have 0 as an answer?
Yeah.
Yes. Can I have 360 as an answer?
No.
No, because right here, there's a parentheses around that. So that says no for my 360, but yes for 0. So my answer is going to be 0 and 180. I can, you know what, I can do it to check to see if it is going to be 0. All I have to do is go menu 6 1. Then all I have to do is carry it over a little bit. So I could go backwards here. So I can go here and then work backwards a little bit. I know it will do it. Actually, how did I do this last time? Oh, I know. Okay, menu 6 1. Okay, so you would just, instead of using the little cursor, you would just say, hey, -5 instead. And then you'd go to, let's say, 5. So you just set your bounds right there, and it gave it to you as 0 0. So, like I said, instead of actually doing that, you can, or you could just look at it, hey, it's there.
Okay.
So,
It's B.
my answer is going to be B.
The last one, you just type it in.
Hold on, I'm jumping over to 12.
Oh.
Jumping over to 12. Trying to work my way down the page. Now, if I am having trouble with this, and you really look at this and just say WTF, okay, what's the best thing I should do here? Calculator, right?
Yes.
So I'm just gonna approximate that. So you would have to approximate every answer. But to get this right, what do you have to make sure of?
Dude. Whoa.
Radian, thank you. How can you tell that this is radian?
Because of pi.
How can you tell that this is radian? My units, right? This unit says pi over 3. That's a radian. Okay? These ones right here, there's the degree symbol. So therefore, that one's degrees. Now, I'm going to show you this one instead on your reference sheet. So there's a negative on the inside, right? Okay. So on the reference sheet, it's right here in the middle. It's right here in the middle. It says sign. If there's a negative on the inside, it could freely just move to the outside. Okay? So it could just freely move to the outside. What if there's a negative on a cosine? It just goes away. The negative on the cosine goes away. But then tangent, if there's a negative on a tangent on the inside, it comes to the outside. Okay, does that make sense?
Yeah. Oh, yeah.
Okay, that's where I get this information. So, if there's a negative on the inside of the sign,
It goes on the outside.
it goes on the outside. So therefore my answer is
C.
very good. Now, where are we at now? We're at 10. So, on 10 here. So, this is, I'm going to plug this in on the calculator again. But as I plug this one in, it's going to be 3 cotangent x degrees squared minus 3 cotangent of x degrees minus 1. So make sure you're plugging it in, and don't forget you have to force the degrees here.
C.
Okay, let's see. 3 cotangent of x degrees close squared minus 3 cotangent x degrees close minus 1. Enter. There we go. We got some answers there. Now, because this is already set to actually find something in that range, that's why you see some answers from the previous problem in there. So let's see, we have a 38.5 0.4 and a 210. Hey, look, it's, or 218, I'm sorry. Look like it has to be,
C.
it has to be C. I don't even have to find them all, do I?
No.
Just by the process of elimination, I could say, hey, look, answer C. Make sense? Okay. So now on number 11. Wait, am I at, nope, I'm at 13, sorry. So at 13. So for this problem right here on 13, I'm going to go through and do this. It says it's the Pythagorean identity, but when we do identities, what's different when we do identities? How do we do it? We don't do it normally. How do we do it in here? How would I do this? Anyone want to take a stab at it? Not calculators. Sines and cosine we change to
Y of X.
x's and y's, right?
Yeah.
So it's going to be, let's see if we can do the algebra here. So y squared plus x squared equals 1. And it says divide everything by cosine squared, right?
Oh.
So I'm dividing everything by x squared. So that's going to be y squared over x squared plus x squared over x squared equals 1 over x squared. Now, what is y over x? I heard it.
Tangent.
Tangent. Very good. Y over x is tangent. So this is going to be tangent squared, right?
Yes.
Okay, what's x squared over x squared?
Cosine.
1, right? X squared over x squared gives me 1. And 1 over x is, so this is secant squared.
Yep.
So tangent squared plus 1 equals secant squared. So my answer has to be,
A.
there we go. All right, on number 11. Okay, on number 11 here, I'm going to have this one again where, now this one is in radian. So what do I have to check on when it's in radian?
The calculator.
In the calculator, but what do I have to make sure?
360.
0 to 360, right? 0 to 360, and I just convert my answer back. So, what do I have to make sure I do first? Subtract 2 cotangent, right? I have to set it equal to 0. I can't do any of these if I don't set them equal to 0. So it's going to be, let me see,
Again,
cosecant, so C of x degrees squared minus 2 cotangent
X.
degrees, right there. So now that I have it in the right mode right here, now I can plug it in the calculator and see what I get. So, cosecant of x degrees close square minus 2 cotangent of x degrees, right there. Hit enter, see what I get.
First one's 45. And the next one.
I got 45 and a 225. It looks like those are the only two spots, right? Okay, so now on my unit circle, what is 45 degrees in radian?
Pi 4.
Pi over 4. What is 225 in radian?
5 pi over 4.
5 pi over 4. So I could just plug these in to the unit circle and see what I get. My answer has to be
D.
D. Does that make sense?
Yes.
Questions? Is there any answers here?
No.
Vanessa, you alright?
Yeah, just looking at it.
Okay. Alright, so let's take a look at 14. So on 14 right here. So I'm going to do the identities again for this one right here. How would I write cotangent as the identity?
X over Y.
It's what?
Y over X over
X
Y.
over Y.
X over Y times, what is sine?
Y over R.
Y over R, but as an identity, it's Y over
1.
1. As an identity, remember, we don't use R, we use 1. Because all my identities have a radius of 1.
Yep.
So, from right here, I have it set up. What can I do from there?
Y's cancel.
Y's cancel, so I'm left with just x over 1, which is
Cosine.
with just cosine.
Oh.
Cosine, right? Does that make sense?
Yep.
Very good. All right, so let's take a look at the next page. 15. This one's using an identity again. Now, the identity on this one is saying sine, cosine, and minus. So let's take a look. Sine, cosine plus, sine, cosine minus. So that means I'm going to be using sine of s minus t here. So for this one is sine of s minus t. So s is my first angle value here. T is my second angle value there. So it's going to be sine of 5 pi over 12 minus pi over 4. So now we're going to do the math right here. But to do my fractions, how do I do my fraction in my calculator?
Replace the pi with 1.
Excellent. Replace the pi with 1. So I'm going to go to the scratch pad here. Replace the pi with 1. So it's 5 over 12
Minus 1 half.
minus 1
4.
over 4. Like that. And then what do I do with the pi?
Pi over 6.
Add just the pi, right? Add the pi onto it.
Yes.
So it's just going to be pi over 6. So now my question is going to be asking for sine of pi over 6. Now, from my unit circle, sine at pi over 6 is just 1/2. I get 1/2 for that one. Now, let's take a look at 17. Now, for 17, this one's a special problem. So, let's see if I could actually give it a little bit more space on this one. I had scratch paper here. Okay, here. I got this scratch paper. All right, so now for this one right here, we need to use this information. So I'm going to draw a graph. So it's an ugly graph, but deal with it. Okay, it says S is this in quadrant 2. So here's my quadrant 2. I'm going this way. Sine is y over r. So my y value is 2. My r is 3. So there's a 2 here, a 3 here. So what's missing? The x value, right? The x value. So I'm going to find the x value. So to find the x value, I'm going to use Pythagorean Theorem, right? So my Pythagorean Theorem is going to be x squared plus 2 squared equals 3 squared. So it's x squared is equal to, let me see, that's 9 minus 4 is 5, right? So x equals plus or minus square root of 5. Now, in quadrant 2, my x value has to be negative, right? X value has to be negative. So this value right here is negative rad 5. And this is my S triangle. Now, we're going to do the same thing again because we use this information for question 17 and 18. Now, the next one says T. T is in quadrant 4. So it's going to be over here in quadrant 4. And it says that sine of T is negative 1 over 3. So the sine is y over r. So the y value gets the negative. The r is always positive. So this is 3 here. So again, my x value is missing. So the x value is missing here. So it's going to be Pythagorean Theorem again. X squared plus negative 1 squared equals 3 squared. So this is going to be x squared is equal to 9 minus 1, right? Yes? So 9 minus 1 is going to give me 8. So x equals plus or minus square root of 8. Now, can I factor that square root of 8?
Yes.
Yes, I could take out a 4, right? So x is going to be, in quadrant 4, it's positive, right? It's going to be a positive 2 rad 2. So this is my t right here. This is my t for this one right here. So I have an s values here and I have t values here. Now, cosine of s minus t. So from my reference sheet, let's see, cosine of s minus t is right here. So it's cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine. So let's see what we have here. So I'm going to use these values. So cosine of s is going to be my negative rad 5 over 3. Cosine of t is 2 rad 2 over 3 plus sine of s, which is 2 over 3, times sine of t, which is negative 1 over 3. So I got all those values from these triangles that we just did here. Are we okay here? Is everyone following on this? Okay. All right, so now as I multiply these together, this gives me a negative 2 rad 10 over 9 plus a negative is going to be a minus sign 2 over 9. So now as I combine them together under a common denominator, my answer has to be B. Has to be B there. Now, this one you cannot put it in the calculator until you get these values. You can't do anything until you did this right here. So this one you can't fake it. You can't try to just plug it straight to the calculator. You need to use this information. Okay? Now, we're going to use the same information on number 18, then I'm going to come back over to number 16. So, it's asking for sine of 2s. So that's a double angle. So sine of 2s, double angle, is right here. So sine of 2s is going to be equal to 2 sine x cosine x. So for this one, since it's s's, it's going to be 2 sine s cosine s. And like I said, this information is from up here, where we're using this information from the triangle we did. So you can't do 17 and 18 until you did this information right here. That's where you have to get all of your stuff from. So it's going to be 2 times sine of s. Sine is y over r. So it's going to be 2 times 2 over 3. That's a 3. Times cosine of s. Cosine of s is negative rad 5 over 3